So we've solved exponential equations where we're able to create a common base by substituting for one or both of the bases. So now the question is, what if you cannot come up with a common base? How would you solve an exponential equation? Well, here are 4 steps to help you solve an exponential equation which does not have a common base. The first step is to isolate the term with the variable and the exponent. Again, the reason it's an exponential equation is because it has a variable and the exponent. Then you're going to take the common or the natural log of both sides, and that's your decision, whether you put log on both sides or ln on both sides. Then you're going to bring the exponent down using the power property, and then finally you're going to divide to isolate the variable that you're solving for. So it seems like a pretty straightforward procedure. And all you have to do is follow these steps. And then again, it's your decision whether you're taking the common log or the natural log of both sides. So let's just take a look at what one of these would look like. Here's an example of an exponential equation, 2 to the x power equals 6. So now typically what we would do, we would say, all right, we need a common base between 2 and 6. Well, unfortunately, there is no power of 2 that becomes 6. 2 to the first is 2, 2 squared is 4, and 2 to the third is 8. So we cannot express 6 with a base of 2, which is why we need a new tool. And a new tool here is logarithms. So what we can do is take the log of both sides. We're taking the log of the whole equation. Log of 2 to the x power equals log of 6. Now the power property says that any exponent can come down as a coefficient. So that's what I'm going to do here. I'm going to take this exponent and I'm going to bring it down and put it in front. So x times log 2 equals log 6. Now this log 2 is a number. This is saying 10 to some power becomes 2. So I'm just going to have to divide by log 2 on both sides. So x equals, again we're dividing by log 2, log 6 divided by log 2. And this is a number that you have to plug into your calculator. Just remember that the log button is on the left-hand side of your graphing calculator. And then make sure you're closing the parentheses after log 6 to put the division sign here. So you have log 6, close parentheses, divided by log 2 equals. And I'll just have to load up the calculator to see what this looks like. But in the meantime, we'll solve the next equation. So while I wait for this calculator to load up, let's just approach this question here. So now, step 1 was to isolate the term with the variable in the exponent. In this case, the term with the variable in the exponent is 3 to the x power. So this 2 is there, but I cannot multiply 2 times 3. Remember the order of operations. This is not equal to 6 to the x power. No. We have to raise 3 to the x power first before we multiply by 2, which means we have to isolate that. The way we'll isolate that is by dividing by 2 on both sides. So if I divide by 2, I get 30 equals 3 to the x power. Just remember, when we were solving exponential equations, we weren't dividing the bases. We were substituting for the bases. So now we would be able to say, 3 to what power is 30? There is no base of 3 that we could express as 30, which means we'll have to take the log of both sides. So now, the last time, I took the common log of both sides. I'm going to do things a little differently this time. I'm going to take the natural log of both sides. So I'm going to say ln of 30 equals the ln of 3 to the x power. All I did was take the natural log of both sides. Again, it's your decision whether you take the common log or the natural log. Difference here, this is log base 10, this is log base e. All right, so we're still going to perform the power property here and bring the exponent down as a coefficient. So you have the natural log of 30 equals x times the natural log of 3. So now this is x times a number. So we'll have to divide by the natural log of 3. So over ln 3 over ln 3. So the ln of 30 divided by the ln of 3 equals x. So now I'm going to my calculator, I'm going to figure out exactly what these quotients are. So we have log 6 divided by log 2. Log 6. Make sure you're closing your parentheses here before you push divided by. Now we'll do divided by log 10. And close your parentheses again. Enter. And we'll say 0.778. So x equals 0.778. For this side, I'll do natural log of 30 and divide by the natural log of 3. Just don't forget to end your parentheses after the 30 here. So the natural log of 30, ln 30, close parentheses, divided by the natural log of 3, close parentheses. Enter. And you get 3.0959. And there we go. So let's work on some word problems here. It says Paul invests $2,000 into an account that bears 5% interest annually. How long will it take his money to double? So if you recall, this is the application of an exponential. A equals A naught times 1 plus R over N to the NT power. So let's figure out all of our information here. $2,000 is our initial investment. So we're going to have equals 2,000 times 5% interest is your R. Don't forget to express it as a decimal. So 1 plus 0.05. And it's being compounded annually. So N is 1. So it's 0.05 over 1 to the T power. Finally, here is our exponent. Here's our variable. We have to determine what's our ending amount. So they indirectly gave it to you. How long will it take for his money to double? So if we're starting with $2,000, that means we're ending up with $4,000. And now here's our only unknown. If you plug in and you have 2 unknowns, obviously you're missing something somewhere. You're only going to have 1 missing variable. So let's clean this up. So we're going to have 4,000 equals 2,000 times 1.05 to the T power. So now if you take a look at this example, this looks a lot like this example, in which there was a multiple of the exponential. In this case, we divided by 2. We're going to do the same thing here. We're going to divide both sides by 2,000. So if we divide both sides by 2,000, because the base of this exponential is 1.05, so we want to isolate this term that has the variable in the exponent. Divide by 2,000, you get 2 equals 1.05 to the T power. So now it's your decision whether you want to take the common log or the natural log. I like the natural log because the common log is just too common. So let's just take the natural log of both sides. I'm going to come up over here now. The ln of 2 is equal to the ln of 1.05 to the T power. Since we're working with logarithms, we can follow their properties, which is why we can take this exponent and put it down in front as a coefficient. So the natural log of 2 equals t times the natural log of 1.05. So now the natural log of 1.05 is a number. So this is a number times t equals a number. So let's divide by that number. ln 2 over ln 1.05 equals t. So let's figure out what that is in our calculator. 2 and 1.05. ln, oh, I have the pen up. ln 2, close parentheses, divided by ln 1.005. Enter. And we get t equals 14.21. Okay, so the initial question was a word problem, so our answer is also going to be a sentence. We're going to say that it will take 14.21 years for Paul's money to double in this account. Last one. We have the population of wolves in a region is modeled by the equation P of t equals 120 times 0.98 to the T power, where t is measured in years. How long will it take for the population of wolves to reach 60? All right, let's see. How long will it to reach 60 wolves? So that's our P of t value. That's our ending value. We want to know when will 60 equal 120 times 0.98 to the t power? Just reading this information, what this is all saying to us is that our population is beginning at 120. It is decreasing at a rate of 2% annually. How long will it take for the population to be cut in half? So now, let's isolate the term with the variable and the exponent. In that case, we have 0.98 to the t power. So let's divide by 120. 0.5 equals 0.98 to the t power. Now that we have the term with the variable and the exponent isolated, we could take either the common log of both sides or the natural log of both sides. I'm going to take the log of both sides. Log 0.5 equals log 0.98 to the t power. Remember, this is a common log, so the base is 10, not important here, but when you're solving equations, it is. Now we can bring the t down. Log 0.5 equals t times the log of 0.98. So log of 0.98 is a number. A number times t equals a number. So we're going to have to divide by log of 0.98. Okay, so log of 0.5 over log of 0.98 equals t. So let's figure out how many years it will take. 0.5 and 0.98 log 0.5 divided by log 0.98. Enter. So we get 34.3. So t equals 34.3 years. So it'll take a little over 34 years for the population of wolves to be cut in half.